Hello students, welcome to your chemistry class. So we are continuing the periodic properties and their variations in periods and groups, and we have completed almost 3 properties, that is your electronic configuration, valency, atomic size or atomic radius. In this video we are going to discuss about the ionization potential. So let's start. So ionization potential means what? It is nothing but the energy required to pull out an electron from the outermost orbit of a neutral gaseous atom in its ground state. So here you can see this is one atom, the middle one it is your the nucleus, and this one is your outermost orbit, and this is your outermost valence electron. Okay, so ionization potential means to remove the electron, okay, to remove the valence electron from the outermost orbit of a neutral gaseous atom in its ground state. So simply ionization potential means it is the energy, okay, it is the energy required to remove the electron from the outermost orbit. As the electron absorbs energy before it can be removed from the atom, the process is endothermic. So why it is endothermic? Because here the electrons absorb energy. So you know, if to release it will be exothermic, and if absorbs then it is endothermic. That's why here it is the endothermic, as your electron absorbs energy before it can be removed from the atom. Ionization potential is measured in electron volts, that is your EV, or joules per mole. Again, this is one conversion. 1 electron volt per mole equal to your 96.5 kilojoules per mole. Okay, so you remember it. Then one example. Okay, the ionization energy of hydrogen atom is 13.6 electron volt or 1312.4 kilojoules per mole. This means to remove the valence electron from 1 mole of gaseous hydrogen atom in the ground state, 13.6 electron volt of energy is required. So do you understand, student? To remove 1 electron from 1 mole of gaseous hydrogen atom, 13.6 electron volt of energy is required. So do you understand what is ionization potential? So remember here in this definition the important words. First one is ionization potential means it is the energy. For what? The energy required to remove the electron. From where? From the outermost orbit of a neutral gaseous atom in its ground state. Okay? I think you understood the ionization potential mean. Then the factors affecting the ionization potential. First one, atomic radius, then nuclear charge. So you have already read that across a period, okay, your atomic radii or your atomic size decreases as your nuclear charge increases. So why is it so? You know, because the number of cells remains the same, but your valence electrons increases in each step. That's why your atomic radius decreases and your nuclear charge increases. Then how it will affect the ionization potential? Larger the atom, more easy it to pull out an electron, and lesser the ionization potential value. So how? So see, suppose this one is your outermost valence electron. Okay, sorry, this is your outermost valence electron, and here your nucleus it is there. Okay, so if the atom will large, obviously the distance between from your nucleus to the outermost orbit, that will also more. If that will also more, then your atomic radius is your large. And if the atomic radius is large, so the outermost valence electron is very far from the nucleus, and it will be easy to remove the valence electron. That means no need to put more ionization potential. Okay, if you will put less energy, we can remove the electron from the outermost orbit. So remember, larger the atom means your atomic radius will be more and your ionization potential value will be lesser. And we can say, so smaller the atoms, the more ionization potential, because if the atom is your small, okay, like this way, the middle one is your nucleus, so you can see the atomic radius. So if the atom is smaller, then the atomic radius also smaller, and if the atomic radius is smaller, then the force of attraction between the nucleus and the outermost orbit will be more. Okay, the force of attraction will be more, then we have to put more energy to remove the electron from the outermost orbit. And if we are putting the more energy, then we are putting the more ionization potential. So like this way, smaller the atom, then more ionization potential is needed. So understood, students? Then nuclear charge. Smaller the atom, more the nuclear charge, more the attractive force on the valence electrons, more the energy required to pull out an electron. Like this way, higher the ionization potential value. So just now we have discussed in case of your atomic radius. So smaller the atom means obviously the more nuclear charge will be there, and more nuclear charge means the attraction between them is your more the attractive force on the valence electron. So more the energy is required to remove the electron, and if more energy is required to remove the electron, obviously the higher ionization potential value needed. Okay, do you understand, students? Yes. So like this way, your atomic radius and nuclear charge affects the ionization potential. So we can say ionization potential depends upon the atomic radius and nuclear charge. Then variation of ionization potential across a period. Ionization potential increases, reaching the maximum value with the inert gas element. So in the previous video, we read that how your atomic radius suddenly increases in case of your inert gas element. The same it will happen in your ionization potential. Here with the periodic way, it is not increasing the ionization potential. It is the increase of your suddenly the ionization potential increases. How? Let's see. The increase is not even and sudden increase is seen sometimes. The alkali metal in a period has the lowest and the inert gas element has the maximum ionization potential value. The elements of the third period show graded variation as given below. So we will see this one is your see this valence configuration, it is not in your course, that is your sp df cell. Okay, so in s, 2 valence electron can stay. Okay, the capability of the each cell I am telling. For s it is 2, for p it is 6, for d it is 10, and for f it is 14. Anyway, it is not in your syllabus, but here only the valence electrons are written. So for sodium, you know the electron configuration, that is 281. Okay, 281. So 1 is your valence electron, that one only here written. So like this way, here the valence electrons are written. Okay, so here you can see the ionization potential of your sodium is 5.1, whereas in case of your magnesium is just 7.6 electron volt. So here you can see the suddenly increases the ionization potential. Why? Let's see the reason. Sharp increase is seen between the ionization energy of magnesium and sodium, and also between your silicon and phosphorus. Why is it so? There is a small decrease in ionization energy between phosphorus and sulfur. It is because in case of your phosphorus, the outermost valence electrons are your 5. Okay, and as here it is divided, in S it is 2, and in P cell that is 3. Okay, that is 3. So these 3 electrons are equally half filled. Okay, so how, see, in higher class you will read, see here 2 3. Okay, this is your electrons. 2 means your S cell is filled, and in P cell we need 6 electrons, but in case of your phosphorus there are 3 electrons in each. That means they are equally half filled, and if the electrons are equally half filled, there is your more force of attraction, and we cannot easily remove the electron. That's why in case of your phosphorus, your more ionization potential required. Whereas in case of your sulfur, okay, sulfur, your valence electron are your 6, that is here 2, that means your S cell completed. Then in case of your P, you need 6, but here like this way the 2 cells are completely filled. Then in case of your sulfur, we can easily remove the electron. Okay, so as compared to your sulfur, your phosphorus need more ionization potential. Then we will see in case of your sodium and magnesium. Sodium has minimum and argon has your maximum ionization energy. So we remember that the first element across a period, the first element is your lower ionization potential value, that is your minimum, whereas your argon, the ionization potential value is maximum, that is your in across a period. Because you know, across a period the atomic radius decreases, and if atomic radius decreases, your nuclear charge increases, and if nuclear charge increases, their force of attraction between them will be more, and if more attraction is there, then more energy is required to remove the electron from the outermost orbit. Okay, I think you have understood. This is, we have finished the across a period. Okay, so let's see something. It is not in your syllabus, but it is some additional information you should know. Okay. Similar variation is found to be true for other periods also. It is more difficult to remove the electron from the fully filled valence s orbital of magnesium than from sodium. So see here, in case of your sodium, the outermost valence electron is your 1, but in case of your magnesium, the outermost valence is 2. So as I told you, in S cell, your 2 electrons should be there. That means in case of your magnesium, it is completed, but in case of your sodium, the electron is in S cell is only 1. So we can say that is your half filled. Okay. So it is difficult to remove the electron from a fully filled valence s orbital. Okay. Then it is more difficult to remove an electron from the half filled valence p orbital in the phosphorus than from silicon. So in the p cell, as you know, we need 6 electrons, but if it is filled half, okay, if it is half filled, that is 3 electrons, then it is also difficult to remove because that is half filled in your p cell or p orbital. That's why your in case of your phosphorus, the ionization potential is more. Then it is more difficult to remove an electron from the half filled valence p electron in phosphorus than from sulfur. It is we understood. It is more difficult to remove the electron from the fully filled valence p orbital argon. So remember your sp orbital. It is remove the electron from the fully filled s valence s orbital, and here also half filled and full filled, both are difficult to remove the electron. But in the S cell, if the half filled, we can remove. The less ionization potential is needed. Okay. Then variation of ionization potential in a group. So we read your atomic radii. It increases as number of cell increases, but the nuclear charge, it increases, but the effect is small. That means your nuclear charge is not very strong down a group, but your atomic radius increases and the number of cells also increases. If the number of cells increases, the distance between the nucleus to the outermost orbits also increases, that is your atomic radius. So your ionization energy decreases down a group. Why? As your valence electrons will be very far from the nucleus, so we need only less energy to remove the electron. Okay? So here you can see how your ionization potential decreases in a group. So you see, in case of your hydrogen, it is the more ionization potential, but in case of your cesium, it is less ionization potential. So remember, down a group, your ionization potential decreases. Why? I think you have understood, but listen again. Down a group, your ionization potential decreases because your atomic radius increases. If atomic radius increases, then the distance between your nucleus to your outermost cell is very far from each other, and as they are very far from each other, their force of attraction is less. So less energy is required to remove the valence electron from the outermost orbit. That's why your ionization potential decreases down a group. So here you can see the atomic radius and their ionization potential. Okay. So this much for today's class. And another thing, listen. If one electron is removed from an atom, that energy spent is called your first ionization potential. Then if another 2 electrons are removed, then that is called yours, and that energy is called your second ionization potential. Then if 3 electrons are removed, and that energy applied is called your third ionization potential. So now tell me which ionization potential will be, the value will be more. That is, so in the first ionization potential, if the electron is not removed, that means we put less energy. So obviously the third ionization potential will be the greater value as compared to your second and first. Okay. So this much for today's class. In the next video, we'll read the next property. Thank you.